we have learned 2 ways to solve systems of equations. We learned to solve systems by graphing. So that's kind of good because it builds off of something we've already learned, which is graphing. It's really good for visual people to be able to really see what's happening there. But it's very limited because our graphs have to be perfect to actually be able to see it. And the solutions really have to be integers because there's no way to approximate a decimal answer off of a graph. No good way, anyway. So then yesterday we learned a method called substitution, which was better because we could then get decimal or fraction answers if that's the real true answer. The process is a little bit lengthy, so there's a lot of places that mistakes can be made. Losing a small negative at one point in the problem is going to change everything all the way through. So it's a method where we have to be really careful, but it is more free in that it allows us to get decimal and fraction answers. Today we're going to learn our third method, which the book calls linear combination. I call elimination, but those mean the same thing. What we're going to do is combine the 2 equations to get one variable to disappear. So our method is that we're going to multiply one or both equations by a constant, by a number. And our goal is so that one of the variables has the same number in front of it but the opposite sign. So like positive 2x, negative 2x. Okay? That's our goal, is to get the same number in front of a variable but the opposite sign. So what we're going to do is add together the 2 equations because then that variable is going to disappear. So we're only going to have one variable left and we can solve for that one, take it back and plug it in. I find most students like this method better. Not everybody. Some people like substitution better, but more students like this one better than the one that we learned yesterday. So what we want to do, and our goal, is to pick a letter that's going to be easy to multiply one or both equations by something so we can get the same number but opposite sign. It doesn't matter which one you pick. Okay, you could choose to get rid of x's, you could choose to get rid of y's. There's not a right or a wrong, but there may be an easier and a harder. Okay? In this particular problem, it's going to be easier to get rid of the x's because I can do that by just multiplying the first equation by negative 2. Whereas there's not really anything nice to multiply the equations by to get the y's to have the same number. You could do it with a decimal, but it wouldn't really be nice. So I'm going to multiply that first equation by negative 2, which gives me negative 4x plus 8y equals negative 26. Make sure that you multiply the whole entire equation. A lot of students forget to multiply that number that's over on the other side. Okay, so make sure you're multiplying the whole entire equation by that number. Then I'm not going to do anything to the second equation. So I'm just going to copy that right on over the way that it is. Okay, so that's our first step. We want to multiply one or both equations by something so that one of the letters has the same number in front of it but the opposite sign. Then what we're going to do is add them together. When we do that, negative 4x plus 4x disappears. I'm left with 3y and negative 18. And that I can solve by dividing by 3 to get y equals negative 6. That's our first answer. To get our other variable answer, we're going to take that and plug it back in anywhere that we have both an x and a y. Okay? It doesn't matter what equation you plug it into as long as that equation has both an x and a y in it. I'll just plug it into this bottom one because that's the easiest thing to draw the arrow to. But it really doesn't matter where you plug it in. Wherever you like the numbers better. So I'm going to get 4x minus 5 times negative 6 equals 8. So that's 4x plus 30 equals 8. Subtract 30. 4x is negative 22. Divide by 4 and I get x is negative 5.5. Then, as we have the past couple days, we're going to represent our answer as a point, negative 5.5, comma, negative 6. Okay? X comma Y, always alphabetical, not what you got first and then what you got second. We always want X, Y. Questions? Okay, so in this problem, is there something that I can multiply just one equation by that's going to make a letter go away? The bottom one by 3 will do it. So that's always what I look for first. Is it possible to just multiply one equation by something and have it go away? This one I can multiply the bottom one by 3 and then solve on through. So why don't you go ahead and take the reins here and finish solving this one. Multiply that bottom equation through by 3. Add them together. That'll eliminate one variable, and then solve for the variables from there. Okay, so when I multiply that bottom equation by 3, that gives me negative 9x plus 6y equals 30. The top equation I'm not going to do anything to, so I'm just going to copy it over exactly as is. Make sure that when you multiply the whole bottom equation. Don't forget about that 10. Students always forget about that number that's sitting over there all by itself. Do the whole equation. And when I add these up, I get negative 7x. The y's drop out, equals 49. So I can divide out, and x is equal to negative 7. Then we're going to take that answer and plug it in anywhere that there's an x and a y. Yeah, question?
Does it matter if you put the negative 9x plus 6y on the top?
It doesn't. No, the way you stack the two equations doesn't matter. So I'll just take this again and plug it into the bottom one because that's the easiest place for me to draw an arrow, but you can plug it into any equation that has both an x and a y. So I'm going to get negative 3 times negative 7 plus 2y equals 10. So 21 plus 2y equals 10. Subtract 21 gives negative 11. And y is negative 5.5. Question. So I get negative 7, negative 5.5. Questions? Alright, in the next one, when I'm looking for what variable to eliminate, I want to say, is there something I can multiply one equation by that's going to make the variable go away? So I want to say, is there a way that I can make a 2 into a negative 5? Well, not with a whole number. I can multiply by a decimal, but not with a whole number. Can I make a 3 into a 5? Again, not with a whole number. I could use some decimals, but I kind of want to avoid that. So what that means is, in this equation, we're going to have to multiply both, or in this problem, we're going to have to multiply both equations by a number. Then the way that I choose whether I want to get rid of x's or get rid of y's is if one of them already at least has opposite signs, then that's at least something in the right direction. So in this problem, I would choose to get rid of x's, but getting rid of y's is not a bad choice. It's just a different choice. Okay? I would choose to get rid of x's here. So to get rid of x's, what I'm going to do is multiply the first equation by 5 and the second equation by 2. That will turn both of them into 10s, and the second one will be a negative 10. So the top equation becomes 10x plus 15y equals negative 5. And the second equation becomes 10x plus 10y equals 30.
Should it be negative 10?
Yes, thank you. So then my x's are all set to go. They've got the same number but the opposite sign, so they're going to drop out. Add up the y's gives 25y. Add up the numbers gives 25. So that tells me that y is 1. Then I can take that back and plug it in anywhere where there are both x's and y's. It doesn't matter where. I'll plug it into the first equation this time. I like those numbers better. They're smaller. It doesn't really matter where you plug it in. 2x plus 3 times 1 equals negative 1. 2x plus 3 is negative 1. Subtract 3. 2x is negative 4. So x is negative 2. So our answer is negative 2, 1. Questions? Yeah.
So you have to plug it into the original equation?
You could plug it into one of like the two purple ones that we multiplied by something. You could plug it in those as well. As long as both letters are still there, we can plug it in. Usually those ones have bigger numbers in them, and I like to avoid bigger numbers just because I'm not very good at arithmetic. So I like to stick to problems that have small numbers in them. But you could plug them into either of the two originals or either of the two right after we multiplied them. Alright, so for our next problem, I want to think about what to get rid of, what's going to be easiest to get rid of here. There's nothing that I can multiply a 5 by to make it into a 7 to get rid of the x's. There's nothing I can multiply an 8 by to make it into a 12 to get rid of the y's. So then I'm going to have to multiply both of them. X's and y's both already have different signs. So on this problem, there isn't even really an easier and a harder. It's just a choice. You can choose to get rid of x's or you can choose to get rid of y's. I'm going to choose to get rid of y's on this problem because I want to talk about something that we can do. One thing that will always work is to just multiply the equations by the opposite one's coefficient. So I can multiply the first equation by 8 and the second equation by 12 because that would make them into the same number. And that will always work. So if you're like, I don't really want to put too much thought into what to multiply by, that will work. Every time, just switch those numbers and multiply them through. But you might end up with some really big numbers in your problem then. So our goal is to just make 12 and 8 into the same number. So I can think about what is the smallest number that 12 and 8 both divide evenly into. Not that goes into them, but that they go into. 24. So I could multiply the first one by 2 and the second one by 3, and that would turn those y's into 24s. Okay? It would totally work to just use the 8 and the 12, but you're going to end up with some pretty big numbers in your problem. Like I said, I'm not that great at arithmetic, so I like to avoid big numbers when I can. You're allowed to use your calculator, so you don't need to be scared of big numbers, but I just like to try to keep it as small as I can. So I can multiply the first one by 2 and the second one by 3, and that'll turn my y's into 24s. So that'll give me 14x minus 24y equals negative 44. The second one gives me negative 15x plus 24y equals 42. Okay, if we wanted to get rid of x's on this one, I could multiply the first one by 5 and the second one by 7. And that would work too. Okay, so lots of choices to what to multiply by. There's not one right answer to that. And when I add them up, I get negative 1x. Y's drop out equals negative 2.
You add them?
Yep, add them up.
Why are you subtracted?
I didn't even know what you
Why are you subtracted?
Because we want the y's to go away, and so since they already have opposite signs, adding is what would make them go away. If I subtracted, then I would end up with like negative 48y.
You can do either, but whatever helps.
Hmm?
You can do either one, but whatever helps.
Yeah. So if you set it up so that they have the same number but the opposite sign, then we're always going to want to add. We could subtract them, then we would want them to have the same number with the same sign. I'm going to take that x is 2 and I'm going to plug it back in somewhere where both letters are, doesn't matter where, negative 5 times 2 plus 8y equals 14. So negative 5 times 2 would be a negative 10, so I'm going to add 10 to both sides. gives me 8y is 24, which gives me y is 3. So my answer is 2, 3.
Can you go over like choosing the constant to multiply by the converse?
Yep. One thing that will always work is to just switch up the numbers, and so multiply the opposite equations by the opposite numbers. So like I could on this one choose to multiply the first one by 5 and the second one by 7, just kind of like taking those x numbers and switching them, and that will always work. Or I could multiply the first one by 8 and the second one by 12, just switching up those y numbers, and that will always work. But if you want to try to keep your number small, then what you want to do is say, what could I multiply the equations by to get the same number? So those y's can both become 24s by multiplying by 2 and 3. So the goal is to get the same numbers there, and one way to do that is to just always flip-flop the numbers, and that will work every time.
Like in this question, in this problem, once we had our x value, then how do you know which equation to plug it into?
Whatever one you want.
Because I did the top one and it was like -8.
Okay, so if I plug a 2 into the top one, I would have 7 times 2 minus 12y equals negative 22.
Yeah.
So that's 14, so I'm going to subtract 14 from both sides, which gives negative 12y equals negative 36. And divide by negative 12 should still give 3.
Unless you go to the
Alright, so in this one, it would work to just flip-flop the numbers and multiply by whatever the opposite equation is. But we could think about doing something smaller than that. So let's get rid of x's this time. What could I turn 6 and 15 into? 30. So I can multiply the first one by 5 and the second one by 2. So that's going to become 30x minus 50y equals 60. And the second one, negative 30x plus 50y equals negative 60. When I add these up, x's go out, y's go out. So there's nothing left on that side, means there's 0 left on that side. And 60 minus 60 is also 0. 0 equals 0 is definitely true, will always be true. So what does that mean? Infinitely many solutions.
What's with this line and the symbol?
That's the symbol for infinity.
Can you
A sideways 8.
Can you put that on your homework?
Yeah. Yep. Yep, that sideways 8 is the symbol for infinity.
Last time probably going to have it.
Alright, in this one, x's and y's both have the same sign, so we're going to end up having to multiply by a negative here. Is there something that I can multiply just one equation by to get a letter to go away? Okay, I can multiply the top one by negative 2. Write down, please. I can multiply the top one by negative 2, and that'll make a letter drop out. So I'm going to get negative 4x plus 6y equals negative 16. Multiply everything in that first equation by negative 2. Second one I'll just leave right as is, and then I'm ready to add them up. X's go away, y's go away, so I get 0 equals negative 1. 0 does not equal negative 1. So that means what? No solution. Your homework is still from section 3.2, and it's the next group of problems, 23 to 37.